Hi, my name is John Krochmally, and I've created these video modules for people needing to understand and apply their skills knowledge to install, service, and maintain technology controlled by automation systems, and particularly the Programmable Logic Controller. Programmable Logic Controllers, or PLCs, are frequently found in many applications involving automation and instrumentation. In this presentation, we will cover the way modern programmable logic controllers utilize examine if closed and examine if open relay ladder logic program instructions. There will be 3 learning outcomes to this presentation. Number 1, identify the PLC scan cycle. Number 2, identify and describe Xic PLC instructions. And then number 3, identify and describe Xio PLC instructions. Let's review the relationship between the intended circuit's sequence of operation to the PLC assembly and its control. Sequence of operation 1. A normally open push-button PB0 shall control a green light LT0. When PB-0 is pushed, the green light LT0 shall illuminate. When PB0 is released, LT0 shall turn off. Drawing an electrical ladder diagram to achieve the intentions of the circuit may be easy. Notice in this example the applied voltage is applied at the top of the drawing. In a typical ladder diagramming methodology, the line devices, or PB-0, are placed towards the left side of the loads, and the loads, LT0, to the right. We can expect that when this circuit is created, according to this diagram, the green light will cycle with the operation of the normally open push-button PB0. If one wanted to place this circuit under the automatic control of a programmable logic controller, this controller would be installed in the center of the circuit. Notice that the push-button switch PB-0 is considered an input field device and is installed connected to the input module of the PLC. The LT0 green light is a load and then is installed on the PLC output module to the right. As mentioned in earlier Introduction to Programmable Logic Controller presentations, the PLC Central Processing Unit, or processor, stores the operating set of instructions for the assembly. The operating set of instructions are often written in a form that resembles an electrical ladder diagram. Towards the top left of the graphic, we see example of the relay ladder logic that controls PLC-connected loads based upon the condition of the input field devices. Towards the graphic's top right, we see in simplified form the method of instruction execution stated as if, then, else. In this example, the instructions read if PLC input module screw terminal 0 contains a 1, then place a 1 in the output module's terminal 0, else place a 0 in the output module terminal 0. Probably the easiest set of PLC relay ladder logic to understand is the Xic, or examine if closed instruction. Xic, or examine if closed, is a basic PLC instruction that asks the central processing unit to verify that its related upstream contact is closed. Or, is the power provided to this contact allowed to travel through and register at the PLC input module? In this graphic, we see that PB0 connected to PLC input terminal 0 is in an open state of condition. Under this condition, notice that the voltage measures 0 volts at the input module terminal 0, and its associated diagnostic LED at the top of the module is not illuminated. Because there is no voltage at the input module's termination, the optical coupler communicates this information to the PLC processor, and the processor records a 0 in its database memory. The Xic, or examine if closed, PLC ladder logic instruction looks similar to a typical normally open set of contacts that may appear on an electrical wiring diagram. Reading this PLC relay ladder logic program instruction, we can understand the intended logic behind this instruction. If push button PB0 is pushed, closed, the LT-0 green light shall illuminate. If the push button PB-0 is released, and thereby opening up the switch, the LT0 green light shall turn off. Just like drawing a typical electrical ladder diagram, the PLC relay ladder logic contains the same rules: line devices to the rung's left side, and the load devices to the rung's right side. Just like drawing typical electrical ladder diagrams, the PLC relay ladder logic can have their line devices placed in series, parallel, or any combination thereof. As per loads used in PLC relay ladder logic instructions, only one load per rung is going to be allowed. As previously mentioned, the PLC scan cycle consists of, in order, scan the inputs, solve the logic of the program, command the outputs, and then update the memory. This cycle is repeated continuously when the PLC controls the system to which it's attached. In scanning the inputs, if the input module screw terminal 0 sees a 1 in its memory bank, then the PLC processor will place a 1 in the output module's screw terminal 0. Else, the processor will place a 0 in the PLC output module termination 0. Doing these steps completes the solve logic stage of the cycle. Commanding the output involves the PLC processor cycling the internal switches, directing the power to the contactor coils contained in the PLC output module. Notice that when the switch S0 is open, the diagnostic LEDs located at the top of the PLC output module is not illuminated. The examine if closed, or Xic instructions, will allow the PLC processor to look at the input module's terminal for voltage. In this example, we see that after examining for closure and registering 120 volts of AC on input module screw terminal 0, the processor understands this to be true, that after examination there is voltage on that terminal. The related processor memory places a 1 in its data register. Solving the PLC ladder logic set of instructions involves the utilization of the if, then, else considerations. Here we see that if input terminal 0 has a 1 in its data registry, then places a 1 in the output terminal 0, 1 registry, else places a 0 in the output terminal 0 data registry. Notice that this achieves the intended operation as requested in the graphical relay ladder logic instruction set. That looks like an electrical ladder diagram. The PLC processor command involves the closure of the S-0 switch, allowing for the electromagnetic effect of the output module coil, and therefore closing the normally open switch to output module termination 0. This could be considered a typical PLC relay ladder logic set of instructions, utilizing the examine if closed statement. Looking at these examples, we can understand that the HOA switch, door heater control, and the occupied mode switches all must close to turn on the rung load. In this graphic, we point out the rung load, that will cycle based upon the switch conditions located upstream. The next set of PLC relay ladder logic to understand is the XIO, or Examine If Open, instructions. The Examine If Open instruction is a basic PLC ladder logic instruction that asks the central processing unit to verify that its related upstream contact is open. Is the power provided to this contact denied travel through to the PLC input module? In this graphic, we see PB-0, normally closed, push-button switch, wired to the input terminal 0. In its present state, we can measure 120 volts AC at this input terminal. The optical coupler reports this back to the processor, and which the processor records a 1 in its data registry. Notice that with this voltage appearing on this terminal, the related diagnostic LED is illuminated and indicates power on this terminal. A push on the push button PB0 opens the circuit, dropping the voltage from the PLC input module terminal 0. The PLC processor places a 0 in its related data registry and turns off the diagnostic LED referencing that terminal. The Examine If Open, or XIO instructions, allows the PLC processor to look at input terminals to see if the voltage condition has been reduced to 0. If the voltage condition is 0, meaning that the circuit upstream is open, then it is true. If the voltage condition is 120 volts AC, then the condition is false. Referencing the ladder logic program instruction set, we can read the intention of the circuit control. If the input module terminal 0 is open, a true statement if voltage is absent, then turn on the red light LT0, else turn off the red light. Looking at the entire PLC scan cycle involving Examine If Open instructions, we see the process involved in solving of the logic. Referencing the Examine If Open, or XIO instructions, if the input module terminal does not have voltage, an open condition, then place a 1 in the output 0 data registry, else place a 0 in the data registry. The next step in the scan cycle will be to command the output devices. Here we see that the push button PB0 is pushed. 0 volts appear on the input module termination 0, and a 0 is placed in the processor's input registry. This condition makes Examine If Open to be true. If input module terminal 0 has no voltage after its examination, this information is recorded in the processor. Then the logic is solved. In this case, the output 0 registry has been assigned 1. The intention then is to turn on the LT0 red light. The processor then commands on the associated output module relay coils, closing internal contacts, and then starting the load. In this graphic, and highlighted, we see the Examine If Open, or XIO instruction sets. Reading this line and applying what we've learned so far, we understand that the smoke alarm detector, low limit thermostat, and the vibration switch need to be in their normally installed condition for this rung to work. The Examine If Closed and Examine If Open instructions are the most elemental examples of PLC relay ladder logic instructional statements used in PLC programming.